Okay, I think we are live. Hello, hello. Welcome to the what is this one? The fourth programming recreational nighttime programming stream. Today we are going to be working on the brainfuck optimization for our compiler in Crystal. I have written out what we're going to do today. First thing we're going to do is something pretty easy. It's right length encoding for repeated operations, so this should be pretty simple. If we have a bunch of increments in brainfuck, let's actually just show an example of this. But if we look at our test folder here, we have a hello, and as you can see, it's very often that you'll need to have consecutive pluses like this to get a number, and this is because there's no way to add multiple more than one at a time. So everything is increments, so all these are just adding one. And the same thing with minus, it only adds one. Same thing with these movement operations for moving the pointer, these only can add one to the movement to the data pointer. So what we can do is actually just count consecutive one of these and just sort of condense them all into one, and that should be pretty simple to do, and it should really help optimize our compiler. And so right now, if we look at the assembly for, let me just see if we even have it. Yeah, so let me quickly compile the hello program, and just to show you the assembly for it. Right, I have to do that. Tests. Okay, so I compiled, nice. And now if we open the assembly for it, yeah, ASM, you can see there's a lot of this. Add byte one, add byte one, add byte one, add byte one. All this happens 65 times in our program for A, just to print out A, for example. I think this is printing out H here, so that's why there's so many plus ones. But all of this can be condensed down to something like that, even though in how it's actually written it won't be like that. But here it could just be condensed to like that, and then we won't have to run so many instructions. And it's the same for moving the data pointer. If we go all the way to where's the data pointer move? Where's the data pointer move? Add one to where DP is pointing out. Add one to DP is pointing at. How deep does this go? Let me make it smaller. So if we go, let's see how far. Wow, this is like a lot. Add one to where data pointer is pointing at. Okay, so right here, add one to data pointer. So as you can see, we can do the same thing here. Right now, there's not a bunch of them like this. Oops, what did I do? DP. Oops. Add one to DP. Okay, cool. So right now there isn't, like, this one doesn't show how many times it could be in a row, but it could be something like this where you have tons of add ones to the data pointer like that, and all these can also be condensed to one thing. So we're gonna do that as well. Okay. Then the other thing, I'm just gonna rerun so we regenerate it. Then the other thing we want to do that I have written out here in my to-do, oops, just right here, this to-do, is I want to allow for simple loop optimization, and this should also be pretty simple. Just before the stream, I was reading this guy's blog post on optimization, and there are a lot of cool ways to optimize brainfuck that are pretty simple. And maybe we'll get into it later after we implement our brainfuck compiler and brainfuck, just for fun. But the real big ones that will shorten up our code will be this one, like using increment and increments, what I just talked about, the run length encoding. Same with this, and this, the simple loops. So this is what we're gonna do, and this is kind of an interesting, thing that you can do, that you can optimize for. Basically, in brainfuck, this will end up making whatever pointer you're at 0, whatever you're at. So whatever the data pointer is pointing at, this will make it 0, which is kind of neat. And so all of this, like, we don't need any jumps or anything like that. All of this will just be this. We'll just convert into a p0 is equal to 0. And this dude explains, what's his name? Is there any art author? Who's the author for this? Nayuki. So Nayuki here also shows how to optimize for slightly more complicated loops, which we'll be doing pretty often, I think, for Brainfuck to be able to do big loops for checking if we're looking at certain letters. So for example, when we take input in Brainfuck, let's say we take A, to check if we're looking at A, what needs to happen is we need to decrement A, whatever the value, the ASCII value is for it, until it gets to 0. And when it gets to 0, we can say, oh, this is A, because we decremented it 5 times and we left the loop. So this will happen pretty often in our compiler, so this will be pretty good. These other ones are also kind of useful, but it would require, and they're not too difficult to implement, but they're not that, like, it won't add too much. It won't add a lot of like performance really, which is all I really care about with these optimizations, just so we can get our compiler to compile something. So yeah, let's get started. Or actually, we'll go through these a little bit more. The other thing I realized is that we can actually, last time I said we can only have a maximum of 13 loops, but I actually figured out a very easy way to double that. And that's because if we look at ASCII here, so what I'm doing right now is if we look at these letters, the beginning of the loop is labeled with A and the ending of the loop is labeled with B. And then next time we like create a loop, then that loop is labeled with C, the beginning of that loop is labeled C, and then the end of that loop is labeled B, which means we kind of half the amount of choices we have for letters. And again, the reason we're making it so simple, the way we generate labels so simple, is because Brainfuck is a very simple language, and therefore we need a really easy way to generate labels that won't interfere with each other. And this is pretty much the only way I could think of. It's pretty easy as well. If we need something a little bit more complicated, then we'll do it. But if we can keep this as simple as possible, that'd be really nice. So, like I said, we are looking. This is going to be the beginning of the loop, and then the next one is the end of the loop. But what we can actually do is this ASCII letter is different than this ASCII letter here. And so what we can actually do is every time we create a label, we can actually create the beginning one with this one, the capital one, and the ending label with this one. And that's also a little bit easier to read. Like we know the beginning of a loop will always be the capital and the end of a loop will be a negative. Or we could even make it like the beginning of the loop is negative and the ending of the loop is capital. But this will double the amount of loops you can make, and hopefully 26 loops will be enough to implement the Brainfuck and Brainfuck. Okay, so going back to our to-do list, the last thing I want to do is I want to write a helper function for printing statements, and this is going to be really important for our compiler when our Brainfuck written in Brainfuck compiler, because we need a way to easily write out stuff and not have to think about so hard what we have to do. So we're gonna have like big blocks of like addings and increments on the data pointers and increments on the whatever's pointing at the data pointer and decrements, because to write anything you have to like move up to that value. And so even if we look at if we just look at our hello example again here, you can tell like this is just writing hello, and like just look at like all this is just to write hello. So in our code, because we're going to be generating assembly that's going to look like this, we're going to have to write code that just generates all this for us. Just generates this in ASCII, because having to do that manually would really suck. The rest we can do manually. The rest of the compiler we can try to do manually, but at least like printing out like trying to print out stuff, we should try to do on its own. Now the other thing is, you might be wondering, well, why don't we add like a a way to easily print strings in Brainfuck. And the reason I'm not going to do that is because if I add that, then our Brainfuck compiler also needs a really easy way to print strings, which like within like implemented in Brainfuck, which is just not, we're just not gonna know. I don't even know how to get started with it. I have an idea how to do a Brainfuck compiler in Brainfuck, but doing anything more complicated like doing like storing strings somewhere, and reserving memory somewhere on that like data pointer list like that, we're just definitely not gonna get into that. So let's finally get started with what we're gonna do today. And the first thing we're gonna do is, like I said, we're gonna do the run length encoding for repeated operations. And if we go to our compiler here it is. We're only gonna implement it for the native version, because the interpreted version is just the interpreted version doesn't have any optimization. All it does is literally run through the program, and like if we look at it here, like literally it just takes the program string and it just runs through it like one by one without even like looking at it, without even like seeing like what's ahead or anything. It just on the fly interprets it. So there's not really any reason to do that, to add any optimizations here really. Like, I mean, we could, but at the same time, I don't know, it just doesn't seem that worth it. And what we really care about is the native compiler anyway, so we're only going to implement optimization there. So what I'm thinking is, for optimization here in this compile method, is we could, so something we could do is, first let's try to do the run length encoding. So every time we encounter a plus or a minus, we're gonna actually like add them all up together. We're gonna fuse them all together just to create one, and that should be a pretty simple thing. So let's do that. Let's start with these guys, since these is like a little bit shorter here. So when we encounter this guy here, we're gonna go ahead and continue until we stop finding. So we're gonna count. It's gonna start at 1 because we've already seen the first the first increment on the pointer, and then we're gonna write a while. So until program IP doesn't equal, that's that. So as long as we're looking at these increment pointers, we're gonna keep running through this loop and this IP. And we're also gonna add one here, so we just move it along. That's the same. We don't need this down here anymore, or we might. Do we? Yeah, we do, because at the end, no, we don't. We don't need it. It'll be like that, because this will run until it's not this, and then the next loop will take care of whatever the next operation is. So that's good. And here, all we're gonna do is add up this like this, or we could actually even do it a little easier. We can actually just store our original placement in the program. So let's do that. Let's see, IP, and then we'll add one here, and then we'll add one here, and to get the count, that's just gonna be IP minus IP. And that should be the amount of times we need to increment the data pointer. So instead of putting count here, putting 1 here, we're gonna put in count. There we go. And it's pretty much that simple, I think. So let's actually implement it for this guy as well. Just like that, until program IP doesn't equal this guy. Oops. This keyboard's a little bit smaller than the keyboard I usually work on, so I just have trouble clicking some of the keys. We'll do the same thing here. 1. And then we will get the count. So the count is equal to IP start. Go. And then down here, instead of 1, we put in this guy. That's the IP. Oops. And we'll do the exact same thing here. So honestly, you can literally just copy and paste this. And we're not even going to bother like generalizing this, because like I said, this is a very simple program, and unless it gets more complicated than this, I don't see a reason that I could just, like, if I need to change, this is never going to change, like, let's be real, this is never, like, I'm never going to have to go back and change this optimization, really. But if I did, then I'll just put it all in a function, if I really need to. So I'm not going to do that now, but it's something you could consider if you want. Another thing I want to do, I just realized, is that the comments aren't being updated. So I'm going to do that as well. Make sure the comments are updated as well. So when we look at them in when we look at the assembly, we can make sure, like, we verify that it's doing what it's supposed to do. Okay, and we could just see at least the sections, like having section them off. Okay, so now we're here, and instead of looking at this guy, we're looking at plus. And honestly, I might make a function for this, because it's just so small, and it would be kind of useful too. So yeah, I might do that in a second. So I'm gonna just put count in here. Okay, and then we're gonna copy this guy. After I make sure this works, then we'll put it in functions. How about that? We'll copy it down here, and if we see a minus, until we don't see a minus, we're gonna subtract. So oops, I did it in the comment but not here, so let's change that count, and let's change here. Oops. And okay, cool. So that should just work, I'm hoping. Check it out. Okay, so crystal build R, and we're built just fine. And now let's run the compiler on hello, which has the most increments that we have. So test hello.bf. What? Oh. Test.hello.bf. And it compiles successfully, which is nice. Let's go to the assembly for it. And if we look at this, there we go. This is exactly what we want to see. So remember that huge file we had? Well, now it's been condensed to, instead of 72 as, we just have one. Instead of 69 as, we just have one. And if we go down here, subtract 5 from DP, that makes sense to go back. Okay, cool. Nice. So I think that's gonna work. I'm gonna make sure of one thing here. So yeah, that's 5. Okay, good. And let's try running it. Ooh, I just messed it up. Perfect. Alright, so we've just implemented run length encoding for our Brainfu compiler, and now we're just going to make it a slightly bit nicer by... I know I said I wasn't going to create a function to do that, but I will. So, in here, I'm going to do it the same way. I'm just going to create a proc, because we don't need it anywhere else. We just need it in this one function. And so I'm just going to call it count ops, and that's going to be a proc that takes in our IP, and which is, what is our IP? I think it's an int, right? I guess we'll find out. It's an int like that. Where's IP? I guess it's an int. It has to be. I'm gonna assume it's an int. 33. Let's see. And our actually, we don't even need this. We honestly just need to return an int 32. That's actually it, I think. And let's do that real quick. So this is gonna be a block. I don't think there's anything. I don't know what will happen if there's not anything I need, like no parameters you can pass in. So I'm gonna pass in. I'll try without nothing first, and if I do need something, then I'll try putting in those two pipes. Okay, so count operations. We're going to take so actually, I just thought about this. We need to put this after we've defined IP. Cool. And after we defined IP, we're going to do IP minus equal, or sorry, we're going to save IP as start, like that. Then we're going to, and I totally forgot this, but we actually do need the character that we're like checking the runtime length for. And until program IP, actually this will be so IP start. This will be IP 2. And the reason is because of actually IP. We don't want IP to change. We just kind of want to get it from the scope above. So yeah. And actually, just because of that reason, we'll make it an input parameter. And if now we have to do this, so that'll be instruction pointer, and this will be the character. I'll just name C. Then IP start is equal to IP, just like that. And then IP doesn't equal, as long as it doesn't equal C, then we continue on this loop here, which all it does is increase IP. And then we can simply return IP minus IP start. And that should be it. So when we convert these into that, let's do it like this. So yeah, so I'm always gonna have to add 1 here because I want to skip it. But do we even need to add 1 here? Yeah. I'm not even gonna, so I'm actually gonna take that off, and instead I'm gonna do this count keys. We're gonna put in the IP instruction pointer. We're gonna put in this guy, and we're gonna put in nothing else. That just returns that, and we can delete this. So let's actually, man, I should have done this for plus because plus is the easiest one to test. But let's actually do this for plus as well, and this, and put that there. Okay, so let's see if this works. This should be just fine. Oops, let's go build df.cr, and can't return use next. Can't return from this, so I guess. Do I just do that? Does that work? Undefined count OPs for top level. What am I doing wrong here? The return type is in32. Let me try one more. Let me just see the error for this. I don't understand the error for this. Can't return from next. I guess it's next instead of return. So maybe I should just listen to what the compiler's telling me. That work? Undefined method count OP for top level. I keep going back to that, even though it's like all I have to do is open it here. So let's see what went wrong. There's always just something wrong with the way I'm like using Crystal. So let's actually see how to do proc again. Proc. Let's see. So we could define it like this, which I think I kind of want to do. I kind of want to define it like this. Maybe just to try a different syntax too. And I'm not sure how this block syntax here works, so I'm going to try that other way it shows how to do it. Let's do that. So delete all this. This will be a little arrow here, and now we create this. So IP is 32, and our C is going to be a character, and I think that's it. Like I don't have to have anything else than that, so that seems fine to me. Yeah, and I can delete that. And it's a proc, so it should be able to access this, the program. Okay, so now it's, I guess I can just leave it like this. So does that compile? I can't figure out why count OP is not found. I cannot understand why that's not being found. Count OPS. Oh, that's why. Keep forgetting it's call. And I can actually just skip doing that. Just do that. it looks better like this. It looks more readable, I think, than using the spaces. This one I think looks fine actually, not using the spaces, but the other one doesn't, I don't think. Like, yeah, it doesn't, yeah, so we'll keep it like that. And now this work. Cool. So now let's try to compile something. Let's do our hello again. And it fails. Okay, so let's figure out why. If we go in, so if we go in here, we get the IP. And at this point, we are sitting at on top of the arrow thing, or on top of a plus. So I think I guess what could happen as well, we need an or maybe here. I can't imagine. So let's actually replace, just I want to make sure that it's happening on the plus, so let's do that and replace this with this, and let's compile it again. Cool, so it was an issue actually with maybe running into the end of file, because if we look at our test, if we look at this guy, no, it shouldn't. Not sure why they didn't like that. So let's go back to this, and I guess I want to see how it compiled the. I want to see the hello is. So maybe it didn't compile it correctly if the other one isn't working. So 72, 71, yeah. So something is definitely wrong with the way it is compiling. So let's go ahead and fix that. But I'm like kind of surprised why it like loops around. So I guess what I also want to do is, like, why does it call this? I guess what it could be is that, oh, okay. So maybe what it is actually, I'm actually really stupid. I just realized we actually need to add count to this. That fixes everything, because I'm not updating the IP here. So that's actually the issue. So I'm gonna go ahead and do that. So this was never the issue. I was just seeing. So that should actually be just fine now. Oops. Here we go. Okay. And let's build. No file to compile. Oh yeah. It's a dumb option thing. Okay, so now if we check out, and if we check out our tests ASM, we should have exactly what I thought. And now let's try to run it. Okay, so we still read. Okay, perfect. So now we just have to finally, all we have to do is replace everything in the. Yeah, all we have to do is replace everything with those functions, with that function I had. So let's quickly do that. Alright. I'm glad we figured that one out. That was a really stupid mistake. But, you know, shit happens. So, here, we'll do count is equal to count IPs, and we're going to put in IP, and we're going to put in this guy here. And we're going to delete this guy, and we're going to add here, and delete these guys. And we're going to copy that, and place it like this here, and this will point the other way. Nice. And let's do that. Let's copy that and put it here too. Cool. 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 Cute. Cute. So that should be it. Crystal build BFCR. I wonder when. Man, I wish I could see when people chat or like alerted me, because I would have definitely answered your question when you were there. Actually, we called this wrong as always. This is call, and this is call, and this is. I can delete that. I think we can. Oops. We can delete this. We can. Yeah. Then we can delete this as well. Cool. And we can here, and we should be good. So we're not adding an extra. We're not adding anything extra. That should be fine. That should be fine. Okay. And to test it, we're actually gonna do. We're actually gonna write a new text here because I want to test. I want to make sure they all properly do the run encoding. So let's do run length. Let's call this run stuff EF, and all we're gonna do is that. So actually, we'll do 1 and 2 and 3 and 4, and then we'll also do 1, then 2, 3, 4. Do 1, 2, 2, 3, then 4, and we'll do 1, then 2, 3, 4. And in between these, we'll add a dot just to. Actually, in between these, what should we do? I guess, yeah, in between these, I'll add an empty loop. There's not going to be anything in these. There's not going to be anything in these, so. So these loops will act more like comments, since nothing will ever run. And yeah, I'm just adding them because, there you go. Yeah, I'm just adding them so, yeah. So I'm just adding them there so it properly does the run length. Otherwise, like, there's no, I guess there's, like, it would catch the new line as an issue. We should probably skip new lines. I just realized, and like spaces, right? Like it shouldn't care about those things. So I guess we should check until it's not one of those instructions in the. I guess we should ignore everything else. So let's actually quickly do that. Good thing we go to function now that I think about it. So here, and also something else we need to do is, and I is less than program dot, I think it's size, yeah. So we can do this like that, but we actually need to put this in the front over here, and goes there, and we can do this guy. Okay. So as long as we're under the program size, we can still keep adding 1. But the other thing is that we actually need, it can't be any of the other like real instructions. So what I'm gonna do actually is I'm gonna create an array here. I'm gonna call this possible instructions, like that. And we're gonna put in all the characters here that are part of the Brainfu language. So that's gonna be, so we're gonna ignore comments. Yeah, we're gonna ignore comments. We're gonna ignore. Yeah, comments will be in there. It's yeah. So we don't actually have to put comments in here. It should ignore that automatically, I think. We should probably like delete the comments from the whatever. We're not gonna worry too hard about how we're optimized this, but we do need to make sure it doesn't stop the run length encoding at spaces and stuff. So let's make sure that we add instructions, all the instructions of Brainfu here. And what we're gonna do is, okay, that makes sense. That's 1, 2, 3, 4, 5, 6. And what were the other ones? All right, these guys, the brackets. I always forget the brackets. I keep pressing the wrong thing. This keyboard's just a little bit too small for me. Okay, that's good. And we're not even gonna bother. We're not gonna bother. We're not gonna bother like writing like a hash thing. Maybe there is like a way to do with like a hash table. Like I just don't feel like looking that up right now. but we could put brackets around here. So if it's not equal to the character we passed in, or and let me think. How do I do contains in Crystal? Crystal contains. Crystal lang contains array. Oh, here's how you do a set. Maybe I should just do a set. Yeah, let's just do a set. And then check if... How do I check if it's something's in a set, though? Is there contains? Contains. Nope, contain. How do I check for something inside an array? Something inside a set. So this is adding to a set. That's kind of neat, I guess. Is this adding to a set? Oh, okay. So I guess I literally don't know what this means. Okay. Alright, let's check array. What's this? So you add stuff to an array using this, which is I think is kind of interesting. Here's how you do a set. Splat. How do you... That's cool, we can have hashes, that's easy. How do we just check if something's inside? I just want to check if something's inside. Like the... Set crystal lang contains element. Set T, okay. Subset of S2. New other. Okay, let's skip down. Inspect includes. Okay, returns true if object exists in the set. Okay, so includes. Okay, that's all I needed. That's so hard. Okay, so set, and we're gonna make this. I think it's like that, right? Is it like that? Where is it? Where is it? Where is it? Yeah, it's like that. It's like with the curly braces. Okay. So that's fine. And here we can keep going. So we're going to use a while instead of until for this case because it makes more sense. So while IP is less than this, and the program is equal to this character, and it's not equal to something inside that set. And we're gonna have to do this. So program IP is equal to C, or it's not included in, so this here, so possible instructions dot includes C, and we'll even actually put this in brackets just to make it easier, and we're going to put this on the second line of that. So let's just do while our instruction pointer is less than the program size, and we are looking at this, but it's not looking at. So it's equal to this. It's equal to this, or it's not part of the instructions. So they should skip any spaces in between things. And let's try it out. Let's go to. Well, let's first build. Okay, that's good. And now let's try running it. Actually, let's go to our tests and let's do run length. And let's put a space here. Let's put a space here. Space there. Let's put a space here. Space there. Like that. Let's actually do one more here. Actually, no. So yeah, we'll leave it like this. We'll put space here. Delete. I'll delete. Let's say. Actually, put a new line there, just to test it out. Okay. So this should print, like, this should have like consecutive going up increments and then decrements and then increments and then decrements. So let's see that. That's run line. And it didn't compile because I have to add similarly defined. Ah, okay, so is it because it can't have empty loops? Let's actually check that. Empty loop.bf, and let's run our compile. Nope, that works just fine. It must be because I have more than 13, I think. More than 13 of those, which is the issue I was having. So, like I was talking about, like in the beginning of the to-do. So let's go into, I think it's run length. And do I have more than 13? I have 1, 2, 3, 4, 5, 6. No, I definitely do have 2, 4, 6, 8, 10, 12. So yeah, I have way more. So here's something we're gonna do. We're gonna delete all this. Actually, we'll do one increment like that, and we'll do 2 decrements like this. We'll do 2 increments. Or actually, we'll do like this. So 1 increment like that, one like that, and we'll do 2, 2, 2, 2, 2. And we'll do 5 here. So 1, 3, 5, 5, 5, and we'll put in a few new lines just to separate them. To make sure the run length encoding works. So we'll do that, and then we will compile it. And so that compiled just fine, and now we can look at its assembly. Cool. Okay, so 1 1 1 1 2 2 2 2 3 2. Oh, so this is not working, like, at all. It is not working at all. So let's go to our guy here, and let's fix whatever it is. So what's wrong? Ah, this is actually, we're gonna this in here. Actually, operation. No, we can't call it operation. We actually have to just inline it, I think. So we'll do. Please give me the crystal. Okay, there we go. And let's do that. That works fine. And then moment of truth. Oops. Okay, so now we got 2 2 2 2 3 3 3 3 4 8 7. Whoa. Like, it went crazy. Like, something is going on here with how I'm doing it. So let's go back here. Oops. Something is just completely wrong. Man, it's so weird how I just can't do these, like, simple things you think. So equal to this for I see. I see. I see. So here's what we're gonna do. If is this equal to C. If it's not, if it's not one of if it's not one of the already known operations, we're just gonna add. We actually do need a count. We actually do need to count because, yeah, it's the instruction pointer is not representative of how of consecutive things unless we just look at those, unless we're not skipping spaces and stuff like that. It's like literally like they're one beside another, so we're not going to do that. Instead, what we're going to do is here we're going to add this one. I guess what we'll do is we'll always add +1 here at the end. And then else. And end. So here we don't really have to do anything, but here in the else, well, it's even easier than this. Like, if we're one of the possible instructions of the program, then we just break. What's it called? Skip? I can't remember. I don't think it's a break, right? I think it's something else, but I guess we'll figure it out later. So basically, yeah, if it's any of the possible instructions we break, and if it's our same letter we don't break, we just keep going, and we increase the IP, and then down here, that, we just return the count, and we delete this. All right. Wow. That was like a super bad mistake that took us forever. We spent like literally, we spent way too long with this, just way too long. What am I missing here? 54. Oh no. What? We can't just add the count now because it's not the IP. Oh, this is what happens when you try to do something simple and you're an idiot. So, is there multiple return values in this? Is there like multiple return in Crystal? Let's see. Crystal method, multiple return values. Okay, cool. Okay, so let's just do that. We can literally just return the count and the new IP. And if we go down here, we actually do count and IP like that. Actually, let's do IP and count. So let's do that. Yeah. IP count. IP count. And fine, take that off. Take that off. Okay. Man, it's like when you're not just focusing on coding, like even though there's no audience right now, there's nobody, like for some reason it's harder to like stream and code at the same time. I don't know why. Just something I'm gonna have to get used to, I think. Okay. IP. Oh, okay. Let's run this guy. Expected new line. Unexpected token new line. Does it want me to do it like this, maybe? Oh, okay, cool. So that's, we're getting somewhere. Does this do what it needs to do? Okay, cool. And finally, please. Okay, 5, 4, 4. What happened here? What happened here? This is not add link to DP. I want to when DP is pointing at. This is just totally wrong. Wow, run length encoding is like, you know, really messing this up this stream. Let's see. I actually shouldn't do this. Yeah, I shouldn't. Because then I'm skipping one. Another moment of truth moment. Oops, I did not do that. I was like, not again. Okay, finally, it does it. So 1 1 1 1 1 5 5 5 5. Okay, we did it. We just finished run length encoding. Wow, first item off the list crossed off after an hour and a half almost. So that is done. Now the simple loop optimization should be also not too bad. I'm trying to think. So let's go to here. Let's see with this guy. So how do I do the simple loop? Simple loops. So the only way to do simple loops is, okay, so there could be no sub loops. So we could, if we see a loop instead of a loop, then we don't do that. The loop has to have, if the loop has a no sub loops and has no input output, that's, yep. It has all movements add up to 0. It's good. And all increments at P0 add up to -1. Okay. We are basically running the loop this many times. That makes sense. So for the increments and decrements of P0, some multiple is added to application. So these optimizations this optimization actually requires new instructions when we do them. So, and also if we look in here, yeah, this is interesting. This is really interesting. So let me think. So we actually have to keep track of these, I guess. Man, I don't want to do that. Okay, so I don't want to do that. So we actually have to keep track of these guys here, like that, because we have to know like how many times. Okay, it's not that bad, but we basically have to simulate sort of like we have to simulate like the stack sort of, and so as much as I don't want to do that, we'll do it. So let's do that. So let's go. Let's start with the. So this only happens. This is an optimization that only happens when we encounter loops. So let's first, and we only need to do it down here, right here. And actually, before we even do that, how about we do this instead? Boom. Just like that. And down here. Boom. Just like that. And over here. Boom. Boom. Done. Yeah. So now we have more like options for, now we have more options for the names for our labels. We have double the options. We have 26. We can do 26 labels. So we just, with that, is that easy. We crossed out this guy, allow for more loops. Okay, and now let's do what we were talking about there. So let's go to our beginning of our loop here. So let's see if, I guess we'll, at the high levels is what we want, like if can optimize, and here we'll write in a separate function just to do that, and we'll do that. If can optimize, if we can optimize the loop, then optimize loop. So if we can optimize a loop, what we want to return? So we want to return like a relative, like increment decrement. So this here, yeah. So if we look here, we're adding, yeah. So we're adding whatever. We have to count these, and this is actually the factor. Sorry, like the factor. One of the like the factor in front of here. So this has a 1 in front of it because of this, because it's moved up. And let's see. Yeah. So okay. So we'll need. So let's write this first. So can optimize loop, and then we'll have an else where we do this instead. There we go. And actually, we'll have a function for this. So in here, we'll see if we can optimize the loop. And then we can actually try optimizing the loop. So first we'll create an array of bytes. So how do I do that? I think it is, let's do dp, temp dp. And that's equal to array, I think it's like this, right? Array uint 8 dot view. Yeah, I think that's how you do it. And now what we're going to do is inside this loop, until we reach the closing bracket, we're going to keep track of the pluses and minuses for each of the data pointers. So let's do that. Actually, let's do until. That's a little bit easier to read for this one. So until we're at the closing bracket, pretty much. Then we're going to add stuff to this. So the first thing we need in here is actually a 0. So let's do temp dump, and we're going to add a 0 in there, just like this, right? Because this will be like the -1 that we start off at, as it says here. So we basically we're gonna -1 from at some point we're gonna -1 from the initial key 0 pointer, and when we do that, we need a space for it, and it could happen at the very beginning, so we need to do that. And every single time we see an increment, one of these, then the other thing is I actually think about is like this could go below, right? So if this can go below, it means that we need to actually be able to go backwards a little bit. So we actually can't like just do it this way, because we can go, if we decrement backwards, and I guess we'd have to insert, right? So okay, so now we have to, this is the temp data. Oops, there we go. And temp data does that, and temp dp is equal to 0. So if temp dp goes to -1, we'll need to move back. We'll need to actually keep track of which is like the 0 location, I guess. Which I guess we're not gonna worry about that, actually. Let me think. Should we worry about it going below 0? I'm trying to think here. If we decrement the program, the instruction pointer, the data pointer backwards, because we can technically do that. Let me think. So I guess, okay. So I guess what I'll actually do is we're starting off at the 0 position, and so we actually need, I think we need a hash set. I think we finally need a hash set for this. So let's see how Crystal does it. I think we actually need a hash table for it. Okay, that's easy. Should be pretty easy. Okay. So the reason we need a hash set is because we can go under the 0, and it's not that easy to do that with an array. Like, we have to insert and keep track of where the 0 of the beginning of the loop is. So yeah. So instead we're gonna do, I think, is there a way to do hash? Is there a way to type my hash? Is it literally called my hash? Oh, just hash. Okay. So let's do that. Hash. And it'll be instruction pointer, which is going to be 32 to, or no, sorry, not the instruction pointer, the data pointer, but like the relative data pointer. And what's the other thing? The relative value. So that's also going to be in it. Okay, fine. I think that should be okay, right? So I guess I actually don't understand. So additional literal for hashes and hash like it consists of the name of the type followed by a list of comma separated key value pairs. Okay. I understand. That's what I want. I knew it was like that. I should have just went with my gut. Oh, I already have it like that, so it's fine. Okay, so there we go. The temporary data pointer is 0. All right, we can finally get started. So, anytime we see an increment or decrement, we have to associate it with like the relative part of the data pointer. So we have to do we actually have to do another switch statement here, and it has to include all these. But there's only 8. Whatever. There's only 8. We'll do it like we'll literally just inline it. There's literally only 8. So which, where was it? This is a case, I guess. While case, yeah. So this is a case. Where was I? Okay. So, case program IP. Okay, and when it is plus, and fuck, man, I hate when it fucking does that. Jesus Christ. Okay, I'm gonna delete this swap file. Oh. So, wait, where did it save my how far am I in this? 1 second, sorry. Okay, we're okay. It's just I press Control Z a lot of times to undo shit, but it Control Z closes, like just X's out, like just nukes out of NeoVim, which is super annoying. But okay. So it didn't take away much. It made this back into that. So this is going to be in 32, and this is going to be in 32 because it's relative. And actually, this is not going to be in 32. It's going to be a U in 8 because that's no, it's not. I'm going to just leave it like that. And maybe I'll do a check to see if it's under the maximum U8 value or whatever. Actually, we'll check the can optimize. Maybe can optimize. We'll do it, and we can check that. We haven't even implemented this yet, so, and we can't add that. Okay, so we'll save that, and we will create this is the data, temporary data, and the temporary data pointer 0, and there we go. Okay. Case, oops, yeah, case program IP, okay. and when. Let's do this guy, when this guy, when this guy, and let's pop these guys. Oops, pop this guy, minus, dot, comma, oops, and open bracket, and what's the default? Else, I think? Yeah, else. Else, we don't care. Okay, cool. So, if we move up, then we do temp p. This equals 1. Temp dp minus equals 1. And here what we'll do is, we will, if temp data dot includes, if it doesn't include our data pointer, then we will add that in ourselves. And data pointer is equal to 1. And otherwise, we will just increment it by. Okay. And then down here, we'll do the exact same thing. If it's not, if the data pointer is not in there, then data pointer p is equal to -1. Else, and data and pointer minus equals to 1. Done deal. Hey, okay. And for the rest of these, we just do nothing. In fact, we could even just, boom, just else on anything else, because we know this is like a valid, like we've already checked here, this can optimize loop is already checked. If there's like a valid loop to do optimization on, so we don't have to do anything else here. So here, oh, one very important thing is we need to add 1 to our instruction pointer. Yeah, there we go. So, oops. If when we run this, once we hit the closing bracket, it'll leave this loop, and therefore we need 1 more to get out. Okay. And now, when we get out of this loop, we can write the instructions for this thing. Now this will require actually some new assembly code, which I don't know yet how to write, but we'll do it. Hopefully it won't take too long. This is the second last thing we're doing. Writing like a helper function to make like brainfuck stuff should be like insanely easy. So okay, let's see. I think this, so here we're keeping track of everything. Here we finished the loop. So now we have to use that data that we got. So, okay, let me think. Well, I guess the first thing I'd like to do is put S on this guy, and we'll put this. We'll just do string interpolation for this. So in here we're going to put the data, and we're also going to put in, well, the DP should be -1 by the time it leaves the loop. So we don't need to check that, but I guess for a sanity check, and obviously to make sure if we don't have any bugs, we'll do that. So cannot type. Okay, that should be good. And now we need to write the can optimize loop. So let's do that real quick, and we'll write it above. It's can optimize loop, and this will take in the program, which is a string, and it'll take in current IP, which will be, I guess, a uint. I don't know. Let's say. Okay. The other thing we have to check is if program IP doesn't equal an open bracket, then we just immediately exit. And this returns a bool, actually. Like that. I think you do that, right? Or maybe it's like that? I don't know. I cannot remember. Let's check. 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 How do I do functions? Where are you, functions? I guess you don't need an explicit return value. Oh, you do. You can. Like that. Okay. Alright. Okay. Okay. So if we encounter yeah. If we encounter an open bracket, if we don't encounter an open bracket, then this is not the right function. And now to see if we can actually optimize this, so we'll do let me think. We actually don't need the can optimize this because I just thought about it. So can optimize a loop and this optimization we made down here, they do actually the exact same thing. So we can actually remove this else here and put it here. And can optimize loop can actually just be a boolean that we set. So let's move this back a little bit for our indentation. There we go. And actually, so our temporary data pointer should be at 0. And so if we go here, can optimize loop is equal to dp is equal to 0. Okay. And what is it? Hash. Second, so dp is equal to 0, that's fine. And at dp0, it's -1. So let's do that. So temp data at 0 is equal to -1. So we can actually do. We'll actually do it like this. So let's remove this bracket here, like that, and we'll dot includes. Actually, we'll do this. So like that. Is there a way to like know what value we're trying to get? So here, guys. Sometimes I wish they had like slightly better examples for Crystal. It's like interesting that allow these the specifications and have better examples for hashes. Okay. So like it doesn't show you how to check what's inside of them, which is like I think why wouldn't you show that? It's like you're gonna make me like look through all this. Okay, so this returns the key value for any key by key. I'm gonna try that. That seems like what I want. Like this. Right? Gotcha. Cool. Wow, it's kind of cool. It's kind of useful. Like, it's a nice way of doing it. Like, put a little question mark after and it'll, like, it's like a different operator. Okay. So, that should be it. Here in can optimize loop, now we can we can optimize, and for now what we'll do is we'll end this like this. for now, and we'll do that like this. So it'll always not optimize, but we can check if we will. So let's do another test for this. Loop, simple loop optimization.bf. Okay, and let's do the example this guy does. So let's go here and let's do the example for this guy, which is this. So go. Let's type that in. Oops. There you go. So that should be it. This should. So let me just make sure. Yeah. And now we have to build. Well, actually, I want to do one more thing just to make sure. I did save it, right? Let me see. Yeah, I did. Okay, good. So yeah, it'll print. It'll print that. So that should be fine. We only have one loop, so it should be fine to print those two things. So I'll do that. And let's try to build it. So crystal build RDF. And oh, whoops, that literally should be just -1. I don't know why. I'm about to delete that. Wait a second. So there we go. Okay, close that, and let me open this guy so I can delete that file. I need to delete it right now because it's really annoying. I'm not gonna save it, and let's delete that shit. What? So I didn't copy the full thing. Oh, he deleted it. Did delete it? I guess. What happened here? Did delete it? Let's check. No. Okay. It might be, you know what it might be? It might be that my thing is too big, so let's make it a little smaller like that. And it might be just capturing a new line for some reason, so let me do that real quick and open up this and copy this. Oops. Go copy. And then we remove that. Okay, and if we... God, I hate having that error. Okay, so let's go back in. Cool. And let's I think did we build it? I can't remember. I don't think so. Let's build. Let's go build. Undefined local variable or method for top level. DP is not. What? DP isn't? There's no DP. Huh. Where did I put DP? Oh, okay. Just didn't check properly. So temp DP is equal to 0, and yeah, so there we go. Build. Nice, clear. Let's run it on our simple loops test. So we can optimize. Nice. And if we look at this, -1 for that, 1 for that, and -1 for that. This is not right. If we look here, it should be +1, -3, and that's it. There shouldn't be, yeah, just +1 -3. Yeah, so P1 is equal to, so that should be equal to 3. So sorry, 1, and this should be equal to 3. That should be 3. Here, I don't know why this is an error. We will fix that later. Let me step back up. So we're getting closer to getting this optimization done. Shouldn't be too bad. Shouldn't be too bad. Okay. Okay. So we do that. Why is this wrong? Why is this wrong? So minus if. So I guess let's see how this would work on our test data. Okay, so we'll come into this loop here, and we will encounter a minus. So we'll go over here. It's the data pointer's at 0, so we will add -1 to that, and then we'll add 1 to there. So we're on the next one. We add 1 to the temporary pointer, so now it's at 1. We added 1 to that, so we go here, and it doesn't include the temporary pointer, which is at 1, and then we set it to 1. That's okay. That makes sense. And then we go around, we add 1 to that data pointer, and then we -3. So go here. If it doesn't include this, then we set it to -1. And then if we see it next time, we -1. So set it to -1, and then it'll back to +1. It'll go around. And now it does include it, so it should. All these little things mess me up, eh? Oh, you know what it might be? No, it's not that. Never mind. So, by the way, the issue we are having with this stuff down here is just that we're actually skipping it. So we never write the beginning loop, which makes sense. Okay, so what's happening here? Why isn't it -3? Why is it -3? So it should come in here 3 times. It should come in here 3 times and should do 1 of these and then 2 of these. So let's do that. Do that. And interesting. So I guess includes might not be the thing I want to use, right? Like it might not, like it might actually want like a key value pair is what I'm guessing. So this will end up being, I think, like it has to be like a key value pair, I think. So let's instead, let's see if there's a way to just check for the key. We could use this, I guess, this, but I do not want to. I want something to check for the key. First key. Has key. Okay, that's the one we want. Has key. There we go. So let's go here. It should work with has key, I think. So, that's way too far down. So, whoops. Whoops. Okay, we're here. All right. And here, instead of, let's delete that. as key. As key. Okay, I think that's it. And let's try crystal, fill, this, and let's try building that. Okay, cool. So that's exactly what we want. We want -1 and 0, we want 1 here, and we want -1 and 2. That should be, yeah, that's literally what we want. So now these are the factors. These are factors actually to the data pointers, to the 0th data pointer. So let's implement that. So okay, so let's go down there and implement it, because we can do it. And we'll delete these guys. Okay, so because we can optimize, we will let me think. So the first instruction, so where's data pointer? The relative, I guess, let me think. Okay, so I guess the first thing I want to do is multiply whatever is in the data pointer right now with I think. So let's let me think. I guess the last thing we want to do, let's just do something easy. The last thing we want to do actually is this. So instruction.call. We actually want to loop optimization and instruction. Do that. Okay, instruction call. And the last instruction of this like optimization will be to do this. So we are at whatever is in cell, we will move whatever is in cell I into RAX. Right? And then we will move whatever is, we'll move 0 into RAX as a byte, like that. Okay. So this will reset it, which is what we want. And then we have to do the multiplication shit. So instruction dot call, and this could be actually really well, it won't matter for the brainfuck compiler in brainfuck, because we won't be able to do this optimization, but this optimization will actually allow for more loops because we're not using any labels. So yeah, that's kind of neat. All right, so I guess the next thing I want to do is I need to iterate through the different values in the dictionary, in the hash map. So how do I do that? Iterate hash crystal lang. How do I iterate? It isn't a numeral, iterable. How do I use iterable? How do I use these? Each? I just want examples. That's all I want. That's all I care about. I just want examples. Okay, each. I think that's all. I think that's what it wants me to use. Each. Select map. Okay, I guess it's each. And each would be, so let's do that. So let's do 10 data dot each. And in here, I think this will be a key value pair. I want to do something like that. I'm not sure if this is how it's supposed to be, so let me actually do that and see if it works. Okay, and does this work? Cool. And let me run it. Cool. That's exactly what I thought it would do. That's useful. That's useful. But I'm actually kind of confused why I didn't get... Oh, it's because I skip over the loop, so that's why. Okay, yeah, that makes sense why I didn't print any errors. And what we'll do actually is we'll skip over the 0th one because that one will always be set to 0. So here, let's take that off. We don't need it anymore. I think we're good. I think we're Gucci right now. So here, oops. If k is equal to 0, then we will just next. Okay. Now what? So on the next one. Okay, so we can do some cool things in assembly now. I think we have we were able to do relative instructions, so we can do something like move into RBX, right? We can move so into RBX we can move whatever is in here, but we can do plus k times, I think it's going to be nothing, right? Yeah, just k, just plus k, because this is adding in bytes. So this will just do it'll inline how much you have to move over the bytes, which is useful. We don't have to edit this. So we'll move whatever is the pointer, whatever is inside of. Actually, how would this work? Yeah, so it's not actually this. Whoops. So it would actually be, I think, this. And I don't think this is valid syntax, but we'll try. We'll try it. So I think this will go like that, k. And we'll use RAX like that. And this is a byte. But yeah, I don't think that's how it works. So instead what I'll do is do that. Right? And then I will do this. Let's see. So now it's an RAX, and RAX has the address to the data pointers. So if we want to multiply something, I think we can do it like this. So we could do mul byte RAX plus k. Actually, we need two things. We need two pointers. We need to store actually the result of p0 multiplied by something. So this is a data 0 right here, and we move that into RAX. That makes sense. Okay, and now we can do the multiplication call. So we'll do mul on RAX and on it would be that. It would be v. So we're multiplying it by the factor. So it should be just like that, like this. That. Okay. And then after that, so RAX now has the value we want. But actually, we should probably copy it somewhere. So what I'll do is copy this into our RBX. So move RBX. We're gonna copy whatever's in RX into RBX to byte. Then we're gonna do the multiplication. So instead of byte there, we'll just do that RBX, just like that, just like that. So now the results should be inside here. I just want to make sure. Is there? Man, I'll figure it out. Like if there's a compilation error, then I guess I can't use multiply. But multiply must be like some word in assembly. And then what we're gonna do is we're gonna move. This should be in one shot, I think. So into cell I plus K. So that's K. And that's a byte. So from RBX, the value in RBX, we're gonna move it to this new byte here. I think that makes sense. I think this is the code. I think this is it, literally. I think. So I guess to find out. I guess to find out if this works properly. Well, the first thing I want to do is I guess check if it even like it even creates like a buildable assembly. Okay, so let's go here, and I don't know where I have next. So I guess it wants me to do that. I guess it can't do that. It's not like a continue statement. Let's see what happens if I use next here. See what happens. I think Crystal told me before that I could just do that. Just use a next statement. Okay, and then let's do that. Okay, operands do not match. So let's go in here. Oops. And okay. And I don't know, do we need this? So we're getting whatever is inside RAX and we're moving it into here. Let's do, I guess, BX, VL. And I'll do VL here as well. And yeah. So build that and then see if that builds. Processed. Extra characters online. Oops. Okay, let's look it up. Mol assembly x86. No function assembly. So when we multiply, we actually want to move, so yeah, so we move whatever the content's in there into BL, okay, and in instruction. So I can move something into AX actually. So in AX, I want to move something to AX. So in AX, I want to move in there this here, right? And then we just multiply by BL, I think. Okay, well, let's see if that compiles. Compile compiles, and then let's check that. Operand sizes do not match. Okay. Interesting. Move. Okay, I see. I see. I think I understand. I think I understand. So let me go back to my thing. Optimax loop. And here we're not doing. Oh, here I put an RBX, but it's actually supposed to be BL. And just please work. That was fine. And then what do the operand sizes not match? How do they not match? Oh, maybe I have to re-add the byte to it. The byte. So maybe I have to add this here. No? It's not like that? Okay, it compiles. Cool. Nice, nice, nice. Let's see it. Let's look at it. Yay. It should have... I was like, no, what happened? Why is it weird? Okay, so it should have... Okay, so it should have done it it should have moved all those, did all that multiplication shit. So first we take whatever's inside of here and we put it into RAX. That's fine. That's the address to the cell, to cells. And then here we take the value of cells and we put it into BL, so this little thing. And then we take whatever, then we move 1 into AX, and then we multiply BL by AX, and then we move whatever is in BL to this area of memory here. We actually need one more step. We actually need one more step in between, because this will modify the like cells, I think. Yeah. No. So cell I plus 1 is not what I think I want, actually. I think what I want here is RAX plus 1. Like, I want this, like that. The address, because this is already, this holding cells, the address to cells, and then we add 1 to that. Dereference it, put the result in there. Right? Right? So let's change that real quick in our implementation here. Okay, loop. So here we do not want cell I plus, okay, we want RAX. And instead of doing this with RAX, we're gonna use RDX, because I think AX might be like part of RAX. I'm not sure. I'm not super sure on that, so I'm gonna change that. And we're putting in something in there, so I don't wanna risk like doing something stupid and like having, you know, spent hours figuring out what's wrong. So I think that's okay. Yeah. Alright, so let's compile this one more time. Let's do that. And let's do that. So that works. Okay, so we move cells into there. We move this into here. Yep. So we move the value of whatever is in cells in here to BL. I think that makes sense. Then we move 1 into AX and we multiply. Yep, that makes sense to me, I think. Yeah, that makes sense, because this is, yeah. And then we move whatever's in there into a new location, into its rightful place. And then it repeats, so then we move. We actually don't need this. We actually can just live with this at the top. So let's do that real quick. Let's do that real quick. So let's go in here and back at the loop section where we do the optimization. So this here can actually be done before. Just like that. And then only this really needs to be redone. Actually, does it? It does. No, it doesn't. No, it doesn't actually. This doesn't need to be redone either. So we move the value of RDX, which isn't changing, by the way. We move that to here. And then we do this multiple times. We literally just... Yeah, that makes sense. And so let's put one more instruction here. Let's first do a little something this. Instruction, call, like that. And then we'll do indents. Let's equal 1. Okay. And down here, indents minus equals 1. Okay. And down here, we'll add a little... So we don't even need this here. We'll move this down here now. And that should be it. So let's build this again. Let's run this. It runs, and then let's see it. Cool, cool, cool. So it does what I wanted to do, which is put the indents. Okay, so these two are done first, where I move whatever value is in RDX into BL, and then we just reuse that value a bunch of times. So I move something into AX, I multiply it by BL, and then whatever is in, oops, AX, this should be AX, so let's actually fix that real quick. So, oops, I don't care about that, saving that, so let's go down here. This should actually be AX. The destination is AX. So let's do that again. Compile. Okay. So here we set it up. We move in the address of cells into RDX. We move in the value of that area within the address into BL. We move 1 into AX and we multiply it. And then we put it into the area that we want to put it in, and then we do something else here. We multiply by, we put something into AX, which is -3. We multiply by BL, and we put it in here. Actually, it's not even we move it in there. We actually add it. So it's not a move. Actually, this is actually an add. Like this should be like that. We're not moving it there. We're actually adding it. Yeah. So, we actually have another thing to fix. So let's go back here. Okay, so we're not moving that result into there. We're adding it to that result. So let's do that. So whatever the result... So actually what we first need to do is move... Let's put something in RBX, I guess. Now we don't need BL anymore, so oh no, we do need BL. So BL, RDX. What can I use? What are the registers again? What are the registers? EAX, AX, BX, CX. So these are the 16-bit ones. And let's do 32-bit, so RCX. We could use RCX. Okay, nice. We can use that guy. So inside of RCX, which I think is just... Yeah, so inside of RCX, we're going to put in the address, this address here. I'm going to add this address. So that should be... Or should I, do I even need to do that? Like, can I not just do something like that? AX plus, like, add Like this is an address, and this will dereference it. This is an address. So let's see what the compiler says about that. The FAST compiler. What does it say about doing that? Okay, yes, operand sizes do not match. Operand sizes do not match. How come? How come they don't match? I guess AX is not a byte, so let's change that real quick. So since AX is not a byte, I think we'd have to do AF, take the lower byte. Right? And add it. And that does work. And if we open up our ASM of it, so now this is what I think this maybe the last time we do it. So we do move the cell I, so cells is in here, then we move the value of that into BL. That's good. Okay, so then we put 1 into AX, we multiply 1 by whatever's in BL. That's good. And then we add whatever's in AL, which was the result of the multiply, into here. That makes total sense to me. We add it, and then we also do this here. We add it. Okay. Now to test this out, actually, we have to write a slightly more sophisticated test here. So let's do that real quick. And so we know that P1. So let's actually do this with letters. So let's do a bunch of. Let's do 65 of these. So let's do A, B, and C, or A and B, I guess. So let me look at what this guy was optimizing with. So he was adding 1 to here, and then 2 away, he was adding this. Okay. So let's do, yeah. So let's do inside of 1, we will put an A. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 15. 30, 60. 1, 2, 3, 4, 5. That's A, so we're going to print that out. We're actually going to put this in these because for now, I just want to see if that prints out A. So let's quickly do a compile. And that. Okay, that's good. Let's do B on the other one. So that's going to be copying this, adding 1, just like that. And then here what we'll do is that the first one's going to add 1, and the second one's going to add 2. 3, or it's going to minus 3. So we're going to actually have to, let's put this a little bit further. This is A, B, C, D, E, F, G. And this is C, D, E, F, G, H. So it should be GH. And let's even add a new line. So let's move 1 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. New line. Then we move back 3, and now we can start our loop. After the loop, what we should get, if we do this, and of course that, so we can print out our new line since the new line isn't changing. We should get, so if we add +1 to G, we should get H, and since we're minusing 3 from H, what is it, GH? Let's just check the ASCII table. So we're at G. If we add 1, it should be H. So G. If we add 1, it should be H. And if we minus 3, 1, 2, 3, we should get E. Okay, so let's compile this. Does this compile? right now it should still compile with, and right now it should just print pretty much the exact same thing. Oh, right. BFC loop simple BF. Oops. Simple loop optimization. Okay, there we go. Okay, so that works. And then let's do test simple loop optimization with ASM. That seems to be fine. So here we add, this is cool. So we're doing a bunch of optimizations here. All right, so it does the print, does the one, and then we do no loop optimization. Okay, that's what I expected. And that should print GH, I think, in 2 different lines. GG. Why didn't it print H again? Let me check. Why didn't you print H again? Why didn't you print H again, actually? That's weird. It's a weird thing to do, not print H. So I guess something went to 0, and it's not what I expected it to go to 0. And I'm not sure. Damn. Let me think. I guess I could look at the assembly to see what's going on, because now it's a lot simpler since I added those optimizations. So, okay, add one to whatever cell I is. That's good. Print. That's good. Add 1, add 72, wherever that is. Print. Add 1. Print. Sub 3, that's good. Okay, then add 1 again. Print. That seems fine to me. Add 2. Ah, I'm a fucking idiot. It is a mistake here. This is just like that. That's all I have to do. And if we compile it, this brain fuck is like brain fucking me, man. I'm sorry. Perfect. So that's exactly the thing I wanted to get. And then when I add this in, it should be H and E on the next line. So let's compile that. Compiles and work. Oh no. Okay. So what did I do wrong? At least, like, I guess nothing was corrupted, which is kind of cool. But like I did do that. I did compile it, I think. Yeah. Compile it one more time. And let's actually check that it has the loop optimization in there. Optimization. The ASM, sorry. ASM. Okay, loop optimization. Cool. So here, I guess we're gonna have to debug this now. Wow, because I'm not really sure what's wrong. I'm not sure. All right, so let's do debugging. I'll be finished very soon, in less than 45 minutes. So if I can't figure this out, I have to always leave at 10. So okay, so let's do this real quick. Okay, so let's quickly fix this. Well, something that's interesting is that because the values didn't change, it actually might be working, because this code runs, like, if we go in here, if it's working, that'd be sick. But if we go into here, this code right over here, it's not being skipped. This is all running. And if it were doing something weird, like, it would change the values in the data segment that we have. So let's quickly go here, and like, the loop isn't being skipped, it's just like adding 0 to shit. Let's add 1 here. Now it should work. Now it should try. And now it should go through that loop. So let's quickly do this. Cool. And then we just run it. And let's see how that goes. And it works. We did it. All right. We optimized two things. We did two optimizations. That's fucking awesome. All right. That is fucking awesome. So something else that I wanted to do before I move on is I want to go in here in tests, and I have a few test files here, empty loop bf, and hello. So I wanna have like an output file, like a test file to compare these two real quick, just so I know. So we did that. Okay, so we're finally done this second to-do item, optimization. And now finally, let's do some print statement helper stuff. So this is going to be just a separate, it's just going to be a separate thing, and it's just going to be like a really small file with a function here that I will just call, what should we call this function? It's really just, gonna like print like what we need here, like a bunch. It's just gonna be since I don't want to waste loops on this. I guess we could do because now we're optimizing loops. We can optimize. Can do this like through optimized loops. So I guess yeah, we could. Like the issue is that we actually can't put these on multiple like cells. So like what I've seen, like let's go to, if we look at hello world here, let's go to brainfuck hello world. Let's actually just go to brainfuck, and we go here to Wikipedia. Okay, yeah. So if we go here, we see the hello world actually does multiple. It actually tries to add. It does to optimize like how to print hello world, and so it uses multiple cells. Like if we go down here, you see it adds two. It moves cells and then it prints, and then it moves cells and then it prints, and then it moves cells and then it prints, and it moves cells and it prints, moves cells and it prints, moves cells. So it tries to optimize it by putting different letters into different cells, and it tries to have the smallest number of code. We're not going to go this far with it because this is just too much. And I guess like we already like these are going to be like loopless things, and so yeah, so the optimization's only going to be for these inner loops. So we only can use one cell for, we can only use one cell for printing it. We can't use so many. Like there's just not enough. Like I don't want to keep track of the cells. So whatever cell we're on is what it's gonna print, is where it's gonna print it. And so at minimum we need two cells. We need one cell to do to hold the value you want to print, and we need the other cell to hold like the multiple, like we need both cells, but the first cell will hold, yeah, the first cell will hold like the value you want to print, and the second cell will hold um the like how we're multiplying it by, pretty much. So yeah, so let's get started on that. So the general, like I'm wondering how, I guess it would be like, what's the least number of pluses I can use for this? And I guess it would be, I guess I'm not going to worry about it too much. I guess what I want to do is just find like like the greatest common denominator. So let's do that. The greatest, or I guess the greatest factor. Like what's the largest I can, no, I have to split it somehow like evenly. Like if it's 25, like I wouldn't want to do, I guess I would do 2 times, like it would be 5 times 5. If it was 12, like I wouldn't want to do 1 times 12. I'd want to do 3 times 4. So I want to basically get to like find the largest two numbers to multiply by. So is there like something for that? How to get largest numbers, largest factors of a number. That thing. Dividing it by the smallest prime factor. So try dividing it by prime starting at 2. In increasing order until you find one that is a factor. The rest of your division is the largest. Hmm. So I guess the best case scenario would be to have squares, right? Because that would be the least number. I'd have 10 pluses for 25 instead of 25 times 1. So I guess we want to find the closest thing to the square. Get the get the two largest factors. Two highest factors in a single number. Okay, so yeah, that's good. Yeah, that's good. And let's copy someone's code. Closest divisors around math square and okay. Let's do this. Like this looks like this is Python and like I mean, okay, let's quickly look up Crystal math. Crystal math. Do I need to import anything? Math. I just have to use math dot. Okay. Cool. And what's integer division? And I guess it's a typed system, so we don't have to worry about that. So okay. Let's copy this guy. Copy you. Thank you, John Coleman, for your contribution to my brainfuck compiler. Okay. Oops. Okay. And we can actually. Oh my god, what did I do? Okay. And we can actually move this outside, obviously, like that. And we'll actually move it below, and we'll call main up here. And there we go. We'll fix this in a second. So math.round. Let it do that. Well, it's because there's a hole in there. This is going to be an int32. This is going to be math. We're going to square root it. That's fine. It should be fine. Greater than 0. Minus 1. And it seems fine. While, yep. And then we do n divided by a, return those two. Okay. Let's actually test this out. So, puts closest divisors of 36, or sorry, 36. Let's do easy, let's do 12. And what is else? Was he testing? Let's do 35 as well. Oops. 35. Okay, and let's try and interpret this, actually, because we don't care too much about building something like this, I think. What did I name it? I totally forgot what I named it. Get print. Space required before colon. It's such a weird... I guess, like, they have, like, syntax that would interfere if that happened, so... For math module. Okay, how do I round? How do I round in Crystal? Round in Crystal. Lang. Okay. Where's the round button? Where's the round button? Floor division. Okay, so division, that's fine. I could use floor division, why not? Like, I guess that's what, like, this is supposed to be floor division, right? So, I guess there's no return values, so I'd rather do that. Yeah, that would like, be better. And I need to find out how to round. How do I round? Is there a way to check the math? Where's the math? Where's the math module? Crystal. Okay. I keep clicking the exact same link. No. This guy. Okay. Where are you? Where's round? Where's round? Where's round? Is there any round? How do you round in this fucking language? Come on. There should be literally just like a function that does it. I realized that no, this should be good. Like this would return uh this should return a float, right? This square root. I guess I want to find out how to round in crystal length. How to round number in crystal length. How do I do that? Round. Do I just use it on a number? Do I literally like do I do this? Is that a thing? Really? I kind of want to... Okay. Is that really a thing? Argument 1 is expected to be int, not float 64. So A. So here's... This is a... Yeah. Yeah. So let's... 2. I32. So 663457. Perfect. Very good. That's exactly what I wanted. Let's now continue with this. So now instead of here, we're going to do A and B is equal to that. And we're going to want to like put in something to generate. So let's I forget everything but how to do parse options. And I don't want to, I guess I could just copy what I have in, my BF. Oops. ebf.cr. Okay, and we'll yoink our parse options. Parse. Oops. Parse. So we'll take this guy. And we'll yoink that over here. For this. There we go. And we will close here. Okay. So instead of file path, we will put in, this is going to be W. We will put in thing. Text. Yeah. Text. Convert given text to yeah. Text. I guess I wouldn't call this text, but there you go. Don't care. Okay. So now let's do this. Text. Let's see if that works. Crystal build. Oops, not build. Print, and I'm gonna put in a word in here. I need to get the parser, the option parser. Dude, what was it again? I actually do not remember, so I have to open up the option parser. And close this guy. Okay. Should be fine. And let's do that. Alright, so we get hello world. It's good. We get the value that we want. And we will set this to nil. And if not text, then we will actually we'll do this unless text, because this is an S thing, so why not? Unless text, we will return, and we will put S. Provide. You need to provide text. Okay. Do that. Okay. So then we get we get the length of this text. So we'll do length size, right? And we'll get a divisors. Okay. And then we can put out, then we can print F. So I guess we, okay, we're almost done here. We're almost done. So I guess we can, trying to figure out how to, is it like string builder or something in Crystal? String builder, Crystal Lang. Is there? String builder. Right, slice bytes, right string. How do I capacity string builder? Cool. That's exactly what I want. So let's do that. So the new BF print is going to be equal to string.build to ring and okay. Alright, so I guess how do I put repeated stuff in? How do I put repeated stuff in there, I guess, is the question. How to add repeated stuff. Crystal Lang. So this shows us that we can do this, but is there any way to just add more than one at the same time? You know what? I don't care. I'm not gonna worry about that. So, is there a way to do... Still scraping over. Times. Okay, cool. That's neat. So A times. And we will, I guess, get an iterator here. I mean, I'm hoping. Right? Like, we have to get something. And then we do string the first set of these, right? And we're gonna add a new line. Okay. Then we're gonna open up one of these guys. I guess. I think that's fine, right? I think that's fine. Actually, yeah, no, we're still good. So here we will move up one. So this is the one. This is the where we're gonna store the times. So we're gonna move up one. Then we're gonna put, what is it, 4 in there, or whatever the amount is in there. The whatever A is, we'll put in there. A new line here, I think. Kind of like the idea of doing, so we'll put it here. Should we even do that? Let's just put everything in one line. What's the point? So then we'll open up a bracket. In this bracket, we will move back. We'll move back one. And we will add E times of the plus. So let's do that. And I just realized this has to go through all the letters. So I will put new lines because otherwise it's gonna be long. But I guess it's not gonna be that bad because I mean what we're doing is already wrong. I just realized like this. I don't know why I did this here. So this would be size actually. This is actually going here like this, and this should go inside of this. So string dot, I think each would probably do it, and then we'll open up here, and then here would probably be a character like that. So then I'll take this guy. Yeah, I'll take all this, put that here, and increase the indent. Okay. Then instead of text, whatever, this will be. Yeah. And then we get the closest divisors. And then we print out this. Move one over. This has to be a word. Just realized. So then we move one over. So we're storing like we want times by. We store all the pluses in there. We open the bracket. We move back. Then we do the same thing here. We add the number of pluses for B. Right? And then we move back the pointer to this here. And we minus 1 from it. Yeah. After we get out of this, then after we get out of the loop, that, and then afterwards we print that letter, and then we start that thing, we start this all over again. So we shouldn't even use this. Instead, we're going to use a while loop. So until, let's do this, I equals 0, so until, so actually no, while's better. While I is less than string dot size, there we go. And that's going to be a little bit better. It's going to be a little bit better. So let's delete this guy and replace this with end. There we go. And instead of C there, we'll call it C. I go C. And then down here, I guess. So if, yeah. So if I equals 0, then do that. Else, and so we want to do actually is we want this to be from now we're like the 0th pointer has whatever the first letter is. So I equals 0, we just set C as equaling that. I guess sorry, the relative is equal to, so here we'll do the relative, that's going to be that, and then the relative here is actually going to be equal to, so how far away do we have to move now is basically the question I'm asking. So the next thing is going to be at string I.org, and we need to go there, we do this, right? So that's the difference between, that's like the difference between the ordinals and how much we need to get to the next one. So I think that should work because this doesn't run at 0. Let's see what it prints. Let's do hello, which we sort of know how it should look like. I'm going to put a new line down here. And what I'm going to do is actually run this. with A and B. Because A and B is kind of easy to tell. Can't define def inside. So, where am I doing that? Ah, no. What? Okay, so we're gonna have to count the braces. So actually, I just realized. I think this is like that. Yeah, I think it's like that. So this do end. That's fine. That makes sense. Unless and yep. And okay. Let's do that again. String.size for string builder. String. So it's not string.size. This is actually text.size. And this is text. And this is text. And this is text. Okay. And the rest should be okay. So again, I keep thinking this will be fine, but I wanna like next option. I don't know why. Like this should, I feel like this should infer that what I'm talking about, but whatever. Actually, I do kind of like that it's like that. So text, text, text. And here. No, like that, yeah. Text option. I know what to do. Here we go. So we'll just leave this as text. That should be okay. Unless text. And we can actually just do that. I think that should be okay. There's no self in this scope. Oh, I see. This is not how you do it actually. You do it like this. Everything's a method, everything's an object in Crystal. Which I actually kinda don't like now that I think about it. Is there like a way to like force this or something? Like, is there... How do I force this? Okay, well, I'm gonna put all this in else right here, because I'm gonna be dealing with it. So, let's take all this. Put that here, and that. And I just realized that we don't do anything with BF print. We should. We're gonna print it. I don't get why this doesn't work. Like, I thought this is how you're supposed to use Crystal. Like, isn't this how you're supposed to use Crystal? Weirding me out, man. Let's see. Okay. 26. It's stuck forever. And I know why. Because, as always, I have forgotten to add 1 here. Can we finish this before 10? Alright, so let's see if this works. Whoa. Wait. Wait a second. 65? What's 65? What's the square root of, what? Square root of 65. 8. So I should do... I guess it can't? Okay, whatever. Okay, I don't care. I literally don't care. Let's copy this into, actually we can just, do that. ab.bf. Okay, and let's make sure that has the right stuff in it. Okay, and let's try to compile it. So, bf, I compiled, and let's check out what it says. Okay. Why not? Okay, so this moves up 1, adds 1, moves down, adds 65, whatever this amount is. We should count this 1, 2. Okay, so it's way more, obviously. Ah. We're printing 0 twice. So let's go back here. We are printing 0 twice. Oh. Aha. Relative. There we go. Let's do this one more time. Perfect. So, yeah, that makes sense. It's literally just 1, so it's going to be 1 times 1. We should probably optimize for that. Like, if it's 1 times something, it should just do 1. Like the 1 plus. We can optimize to that. Why not? We can do that. We can do that. We have a little bit of time. Why not? We can do that. So, before I do that, though, I need to fix the printing of it. So let's do that first. df.print.cr. Okay, and it will. So we need to actually move it back before we print. So we're gonna do this print. So we're gonna move it, I think, right back. So it's back at 0, I think. Then it prints, and then when we go back up here, it'll. So this, I think this should restart it. This will print. It'll go through the loop again, so it'll move it up. It will add a bunch of pluses. Move it back down. I think that could work. I think that works. Cool. Perfect. 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 Cool. And even, you know what? What was I gonna do after this? Optimize, right? Do a quick optimization. That was a good. This is a good test. So lucky that like we try to prime them. I wouldn't have thought of that about that, honestly. So yeah. Rent. Okay, so we go into here and we figure out that if A equals 1 or B equals 1, then we do this. else we do this. Actually, if doesn't equal 1 and doesn't equal 1, then we will do this. So this is the case that, you know, it's most likely, I think. And down here, we will do if a equals 1, then a equals b, and there you go. So this will just make it so a is the one that has stuff. So let's do a times I, and here that, and we will close that. This, and that really should be it. Yeah. Add a new line here. I guess. Well, this is actually wrong, actually, because it could be like negative. Like it could be going down negative. And so we have to actually check for that. I just realized. So here, relative could be negative, and so if I greater than 0, else and a times and we have to actually probably minus this. Actually, it's here. Like if this is negative, then we'll go here. Negative. It's always positive. And we'll do the same thing down here, just a simple if statement for this. If b is greater than 0, do that. Else b times. That's actually just one line, it's so simple. There we go. And this needs to be negative b, like that. So let's one line all these guys, just because they're so simple, and I want to keep it so clean. Good. 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 Oh, and this guy. Done. Okay. Sick. And we have this, but now we have to print. So I think we just do that and have a new line. I think that's it. So let's try this out. Oh, I put it into a file, but whatever. Oh, there we go. So I think that should do it. So the both of those ended up being like you have to remove them. Let's compile it. So we'll put it in PPF. Yeah. Cool. Good. So now let's do a longer one. Let's do a hello world situation. Hello world. Yeah, why not? Put it in there. Damn it. Damn it. In closest divisors? There's an issue in closest divisors in 28. So let's check that out. In 28. In closest divisors? Oh. Wait a second, wait a second, wait a second. 10 in main, 28 in closest divisors. What? But it's not telling me. It's not telling me. Closest divisors. Arithmetic overflow. Wait, is the first? Oh, I see. Wait, sorry. One sec. It was, what is it, 69 I'm supposed to go to? How is this failing? How is this getting an arithmetic overflow? S and put S and let's and wrap. Okay. It does not want to print that. How about we? I don't know. I don't know. It's getting kind of late. That's stupid. Okay, and let's print that. Okay, so now it looks, that looks like it could be Hello World. That looks like it could be Hello World. Yeah. Okay. And let's compile it. That compiles. And if we run it, maybe. Wow. It happened. It worked. Now I want to try something. Does this work with the \n? Like, what happens if I do that? Right? Yeah, it's not gonna... I guess it's not gonna print that out. But does it work? Like, does it? Oh, we have to compile it. About to compile it. Okay, so it does print out the \n, but it's like, yeah, it's like that. So it doesn't matter because we can add it in. I guess not. I guess we'll actually do. We'll make our little program do it. So let's do that real quick. Make it at the very end. Oh, all we have to do is something simple, even simpler. So all we have to do is, so text. All we have to do is add a backslash. I think that should be. Maybe that works. So let's do that. And let's put that in BF. Alright, and then we have to compile it. Alright, okay, so that's pretty much it. Anyways, thank you guys for watching. That was a very long stream, but we did quite a few things which I thought was interesting, so yeah. Thank you guys for watching. See you in the next one.